So let's have more exercises about implicit differentiation. So it says here, find the equation of the line tangent to the curve x squared plus y squared is equal to 25 at point 3 comma negative 4. So first thing that we should do is again get the implicit differentiation of x squared plus y squared is equal to 25. So we will get x squared plus y squared is equal to 25. And again, first thing that we should do is get the derivative of both sides. So we will do d dx and then d dx on the other side as well. Then we will have x squared plus y squared. This is equal to 25. And then what is the derivative of x squared? That is just again 2x plus the derivative of y squared is just 2y. But then again, when you are getting the derivative of y, always write dy dx. So we have dy dx. And then equals, the derivative of the constant is again 0. So this is now 2y dy dx is equal to negative 2x. And then solve for dy dx. Divide everything by 2y. Divide everything by 2y, giving us dy dx equals, this will be cancelled out, so we have negative x over y. So we are asked again to find the slope, the equation of the line tangent to the curve. So what we're going to do is, to get the exact value of our slope, we will gonna make use of the point. That's 3, negative 4. So we have 3, negative 4. So all you have to do is plug these values. So our slope will be what? Our slope is just a negative 3 over the negative of 4. Or this is just what? This is just 3/4. So this will be our slope. Now using the point slope form, we have here y minus y sub 1 is equal to m times x minus x sub 1. We can actually write the equation of this tangent line. So we will have y minus, our y is 4, so that will make us plus 4, equals, our slope is positive 3/4. So you have 3 over 4 times x. Our x is 3, so that is minus 3. So this will now be the equation of the line tangent to this curve. So we'll try to plot that one. So let's say x squared plus y squared equals 25. And again, at point 3 and negative 4. Where is that? Alright. So again, based on our computation, our equation is y plus 4 is equal to 3/4 times x minus 3. So let's try to plot that line. So we have y minus or plus 4 equals 3 over 4. Then we have x minus 3. So as you can see, this line here is again tangent to the curve at 0.3 comma negative 4. So our answer is correct. Let's have the second example. Alright. So we are asked to find the derivative dy dx of x squared, x cubed, sine y plus y is equal to 4x plus 3. So how are we going to solve this? So again, all you have to do is get the derivative, differentiate both sides. So we will do d dx of x squared sine y plus y, and then again equals d dx of 4x plus 3. So if you notice here, this is actually what? This is a product. So we are going to make use of the product rule to find the derivative. So again, the derivative of the first times the second, and then plus the derivative of the second times the first. So we will get derivative of x squared is just x 2x. Wait, this is x cube. This is x cube, so this is 3x. Let me just correct that. Oops. So this will be 3x squared, and then multiply by the second, which is just sine y, plus, again we are differentiating y, so again every time you differentiate y, always write dy dx. So we have dy dx of sine y. What is the derivative of sine y? That is just again cosine, right? Cosine y. And then times the first, we have x cubed. And then let's do here. What is the derivative of 4x? That is just 4. And again, constant is 0. So far we have this set up. So what we're going to do is again, isolate. I forgot, we still have plus dy dx. Alright, for this part here, the y. So again, what we're going to do is isolate dy dx and then move the rest to the other side of the equation. So we will get this is, let me just, x cubed, and then cos y dy dx plus dy dx. So plus dy dx. This is equal to what? Equal to 4 minus 3x squared, and then sine y. And then we factor out dy dx. So this will give us dy dx. What will remain now is what? We will now x cubed cos sine y, and then plus 1. And again, this is equal to 4 minus 3x cubed sine y. And to solve for dy dx, divide everything by, let me just grab and copy that. Divide everything by this. Alright, so our final answer now is what? So dy dx is now dy dx. So dy dx is equal to this. Alright, so this is our dy dx. So 4 minus 3x squared sine y over x cubed cosine y plus 1. Now, what about this problem? So, find dy dx for y defined implicitly by the equation for x to the 5th power plus tan y is equal to y squared plus 5x. So, again, what we're going to do is differentiate both sides. So, we will have dx times 4x to the 5th plus tan y And then this is equal to, again, derivative of the other side. This is just y squared plus 5x. And again, we are going to take the derivative. What is the derivative of 4x to the 5th power? That is just 5 times 4 is 20. So we have 20x to the 4th plus, what is the derivative of tangent? So again, the derivative of tangent is just secant squared. So we will write plus secant squared y. And then again, that is y, so we will write dy dx equals derivative of y squared is what? 2y. And again, dy dx plus derivative of 5x is just 5. So what will happen now is we are going to group together dy dx. So what I'm going to do is simply move secant squared y dy dx to the right side. So I will get 20 x to the 4th minus 5 is equal to 2y dy dx minus secant squared y dy dx. So dy dx. So factor out dy dx. I will get dy dx. So this is equal to 2y minus secant squared y. And then at the other side, I have here 20x to the 4th minus 5. And again, solve for dy dx. What I'm going to do is divide everything by 2y minus secant squared y. So let me just I've lost my cursor. Alright, so this is just divided by 2y minus secant squared y. This is also 2y minus secant squared y. So therefore my dy dx is now this. So copy, then that one, this is just equals dy dx, dy dx.